Hi everybody, my name is Taylor Northrup, and for our seed germination project, I have chosen the pollutant baking soda. Baking soda is resembling road runoff in this experiment because my hypothesis was that petri dishes that contain more baking soda will have seeds with fewer sprouts. This is because baking soda takes away a seed's ability to soak up water, changes its pH levels, and increases its salinity. Baking soda is a safer alternative to other pollutants, such as detergents. I found baking soda to be very easy to dispose of without hurting the environment after my experiment. To create this experiment, first pour 100 milliliters of distilled water into a large beaker. Then, pour 4 grams of baking soda into the beaker and stir it until it's dissolved. To make your 1% solution, add 5 milliliters of the original baking soda solution into a cylinder. Then add water until you reach the 20 milliliter mark. For each next solution, you add an additional 2.5 milliliters of the baking soda solution. For example, for the 1.5% solution, you would add 7.5 milliliters. For the 2% solution, you would add 10 milliliters. For the 2.5 solution, you would add 12.5 milliliters, and so on. And then you fill with the distilled water until the 20 milliliter mark on each one. I still had my remaining radish seeds left over, so I used those for this experiment. For each petri dish, I placed 5 seeds in a paper towel inside of the petri dish for each solution. Finally, carefully place the petri dishes in a dark place for the next 5 days. On each day, record how many seeds have sprouted. On day 1 and day 2, I had no seed sprout, which was pretty much as expected and didn't really surprise me much. On day 3, I began to see seeds sprout in the petri dish with no baking soda added. On days 4 and 5, the petri dish with no baking soda grew 3 sprouts, the petri dish with 1% solution grew 2 sprouts, and the petri dish with 1.5% solution grew 1 sprout. The 2%, 2.5%, and 3% solution had no seed growth. I also included my charts here that show the percentages of seed germination for each solution. You'll see that the 0% solution has a 60% germination rate, the 1% solution has a 40% germination rate, and the 1.5% solution has a 20% germination rate. The 2%, 2.5%, and 3% solutions have a 0% germination rate. I couldn't get my charts to fully upload as well, so I included a link to them right over in here. Overall, my hypothesis was supported by my conclusions. In the petri dishes with the lower baking soda solutions, there were higher amounts of seed germinations. In the petri dishes with higher amounts of baking soda, there were no seed germination at all. This supports the conclusion that baking soda acts as agents involved in road runoff as it increases salinity, alters pH levels, and creates an inability for the seeds to soak up water. Baking soda in this experiment resembled road runoff, which can inhibit the rate at which seeds germinate. To help prevent road runoff, we can all try to use environmentally friendly cleansers that contain safe ingredients, such as no harsh chemicals or pesticides. You can also wash your car at a place that recycles or properly takes care of the water, and furthermore, properly maintain your vehicle, as oils and fluids on and inside of your car can be bad for the environment. You can also pick up after your pets, as their waste can contribute to the contamination. Thank you so much, and have a great rest of your semester.